Hi, folks. We're just waiting for a few more people to start dropping in, and we'll start our presentation. Welcome, everyone. Oh, and if you have questions, feel free to drop them in the chat. All right, it looks like we can get started here. As people drop in, feel free to ask me to repeat something. We only have half an hour, so this is going to feel a little bit quick, but we'll try to get through as much as possible. I've also prepared a GitHub repository that I'll share towards the end, but it's also available in the slides. You'll find a lot of links for resources in the slides as well. So let me start here by sharing my screen. All right, welcome. This workshop is going to be about building React decentralized applications with TypeScript specifically. So the specificities about TypeScript will kind of lead us to work with a specific set of relatively new tools, which we're going to be talking about today. And of course, other tips for how to be generally a big dApp energy person. My name is Faisal. I'm from the Hypotenuse Labs team, and we are one of the sponsors for Hack the North 2021. Okay, so a little bit of history about blockchain and what is blockchain. There was this island called the island of Yap, and in the island of Yap, they used to use these super large stones as a way to transact, and these are limestones that could weigh tons. And you can see here, it would have this hole in the middle where you can put a pole through it. And it would take many people to actually lift these rocks and move them from one place to another. So as you can imagine, this was a rather difficult way to transact. So they needed to come up with a solution that didn't require them to move the rocks all the time, but still recorded some sort or still created some sort of a record of these transactions. In most parts of the world at the time, or in most empires, these systems were centralized, but not in the island of Yap. So over here, what they did is they actually had every person who lived on the island have a mental record of all the transactions that would occur in the island. Who did it go from? Who did it go to? How much was the transaction? I guess in rocks. And they even had smaller rocks for like smaller denominations. But essentially, doing that and propagating those transactions to everyone in the island and having them keep a mental record of these transactions is a super early version, or the first known version of a blockchain, only it wasn't recorded on computers, it was recorded in people's minds. And this is actually exactly how a blockchain works. I mean, conceptually at the very least. So it's kind of an interesting thing that the idea of blockchain is not something that is entirely new to us, even though the technology of blockchain is. And then when we say decentralized applications, really what we're saying is applications that run or transact with the blockchain without being centralized in a single server. As we all know, blockchain in general is decentralized. There are many reasons why we need decentralized applications, obviously the big one being trust, but also when we moved from this idea of intranet, where, for example, you would have a single server in a single company, and only the people connected to that company's network can access it, and then came along this bigger thing called the internet, that took us a whole leap forward. And that's what blockchain is doing right now, or decentralized applications are doing for a lot of the things that we commonly use. A little bit of a funny picture here. Most of the times when you're explaining things related to crypto or blockchain, you think you're having like a super civilized conversation and everything makes sense. You often look like the picture on the right, so just a heads up. And then another thing you'll notice is people are super interested in learning about when to buy and sell, a lot more than they're interested in actually understanding the technology behind blockchain. You can look at YouTube for some proof on that. Okay, so a little bit of a serious note here. When we're talking about the stack from an infrastructure perspective, there are many layers that get involved. The lowest layer being the settlement layer. That's the actual blockchain layer, right? So this is the layer that holds the decentralized ledger. This is the layer that holds the record of the transactions. So when we say EVM or when we say the Ethereum network, we're talking about the settlement layer. One level above that, we have what we call the asset layer. And if you've ever heard fungible, non-fungible tokens or NFTs or just tokens in general, we're talking about the asset layer, which is something that runs on top of the blockchain. It allows one layer of abstraction. It allows us to build things around the blockchain infrastructure. One level above that, we have what we call the protocol layer. This is where exchanges and really like most of the time at the moment is functional activity is taking place, or functional infrastructure is taking place. So if you've ever used something like SushiSwap or something like PancakeSwap or any exchange for that matter, we're operating at the protocol layer. One level above that, we have the application layer. These are things that we use on a day-to-day basis. So centralized exchanges or even something like MetaMask is something that we can think of at the application layer. dApps that we're going to be looking at today are also things that run at the application layer. And these things interact with everything that we've just mentioned. And at the very top, we have something called the aggregation layer. These are, you can think of them as applications that talk to many other applications. One example of this is something called OpenSea, which basically allows you to look at many NFT tokens, and even an exchange, a centralized exchange, can be thought of as an aggregator. So for example, Binance is something that offers a lot of applications within its application. So you can think of Binance as an aggregator as well. By the way, everything has sources here at the bottom, so feel free to click on the source and read the full article if you're interested. Okay, so let's talk a little bit about the flow of a decentralized application, like what actually happens and how do we interact with it. First thing you're going to need is something called MetaMask. MetaMask is a plugin that has this little wolf icon. You can see on the top left, you can see I'm pointing to it with my cursor. And MetaMask allows you to either connect to other wallets. So for example, a hardware wallet, here we have it on the left side, but it is a wallet in and of itself. So you can even feel free to ignore this left side here and assume that MetaMask is the wallet as well. It exists on your computer, so it exists locally on your machine, even though it's within the browser. And then, as we said, MetaMask is contained within the browser, so it's an extension that allows you to connect to either dApps, or it allows you to connect to the network. So when an activity happens on a decentralized application, such as, let's say, buying an NFT token, the first thing that happens is you have to authorize MetaMask for that activity to happen. And then from there, the decentralized application hence MetaMask, in our case, they exist all on the one side, is transacting with the Ethereum network. It's transacting with the EVM where the smart contracts live. So we cannot change the smart contracts directly. We have to do things like signing transactions or sending transactions, and we do that through MetaMask from our decentralized application. It also allows us to make sure that we're confirming these transactions and they're not just happening on their own. An extension of that, or a more complicated version of all of this, would also include a hardware wallet where the asset is actually stored, or where the keys to the asset are stored. It's always stored in the network. But generally speaking, we use MetaMask as a wallet. However, it does allow you to connect to hardware wallets. We're not going to go into that today, but just for your information. Okay, a bit of a funny thing. My boss actually asked me to include a bunch of Doge references. So Calvin, this one's for you. This one's for us. And yeah, such coin, much profit. Actually, I'm just going to pause here for a quick second and take a look at questions, if there are any. Not so far. Okay, we can keep going. Feel free to drop them in either here or Discord. Okay, so we've discussed the stack from an infrastructure perspective. Now it's probably worth it for us to talk about how do we do this? Like if I wanted to build an application, I know React, I know TypeScript, where do I go from there? First thing you want to do is install MetaMask, and that's at the very top of our stack here. This is the thing that's going to allow us to either have a testing wallet or have a real wallet. During development, you're only going to be using the testing wallet. So once you install MetaMask, make sure that you're actually either connected to localhost. This is not a number. This is not a real number. I'm not that rich. I wish. But you can also choose testing networks. So for example, Rinkeby is another testing network, and you can request Ethereums from faucets and things as such. And then you can even have multiple accounts. So like in this case, I have 1.9 testing ETH within the Rinkeby test network. But if I switch the network to localhost, for example, I should have something that reads an entirely different number. Okay. Next level below that is our actual application, which we would build with React and TypeScript. You can use something like create React app CLI to get this going with the TypeScript template. One level below that, we have something called TypeChain, which is a relatively new tool for generating TypeScript types with or from Solidity smart contracts. So Solidity, which is the one level below that, is the programming language that we use to build smart contracts on the EVM. And it doesn't have the same kind of type definitions as we would in TypeScript. So TypeChain allows us to essentially make the Solidity world or the Solidity definitions connect to our React definitions or the definitions that we're using in our application. And then finally, at the very bottom, we have something called Hardhat. And then other tools previously, such as Ganache, existed, but the latest one is called Hardhat. What Hardhat does is it allows us to run a simulated blockchain, a simulated Ethereum blockchain locally on our machine. So instead of connecting to a testnet like Rinkeby or Kovan or the other ones that Ethereum has, we can just run Hardhat locally and just connect to localhost, even with MetaMask, right? Just like you saw me do in the beginning. The alternative to using Hardhat is to subscribe to a service called Infura. Infura allows you to just use an API connection to connect to any testnet. Again, you don't have to run things locally. You can just work on the rest of the stack and let Infura worry about running the actual chain, be it a test chain or a testnet or the mainnet. Okay. We're going to look at some examples of all of these things in just a second. Okay, so here are a bunch of steps that we would have to do using the tools that were just mentioned in order to get up and running with the code. At a very high level, we want to create our smart contract with Solidity. A lot of templates for smart contracts exist. Oftentimes, you're probably not going to be doing something entirely new. Like, for example, let's say I wanted to create an NFT smart contract. There are already templates for having these smart contracts. You don't have to write it from scratch if you're not doing anything that is super custom. And then the second thing that we're going to do is run hardhat or start hardhat, which will allow us to have a local version of the blockchain running. Then what we want to do is we want to deploy the smart contracts that we've built or that we've written to our local blockchain, which is running with hardhat, or to a testnet. It depends on how you want to do your development. Most likely you're going to start local, then testnet, and then finally do the real production deployment to the main network. All deployments require you to have some Ethereums, whether it's some ETH coins, whether it's test coins or not, whether it's a local chain or not, you have to have some of them. The nice thing about hardhat is it starts off your testing network, or starts off your local network with a bunch of accounts that you can import into MetaMask and do some testing on, and it starts off each account with 10,000 ETH. Okay, the fourth step, or the next step, is to generate types with type chain and make sure that we're able to see them. We're able to kind of read them in TypeScript. The step after that is to just run a create React app, or build your React app however way you want, and make sure that TypeScript is in there so we can make use of the types that we've generated with type chain. Then we want to import and connect to the smart contracts. So what I mean by that is we now have our smart contracts deployed onto the chain. What we want to do from our application is we want to be able to connect to those smart contracts through the address that it was launched at, and make sure that we can read and potentially write to that smart contract. Hence this authorization with MetaMask Bit. So one thing that the tools that we're using are going to help us do is, from our React application, authorize any transactions that we want to send into the blockchain using MetaMask. Right? So this is all happening in the browser. Within our browser, we have our application. Our application wants to talk to the blockchain, and it does that through MetaMask by signing transactions. And that's, I guess, step 7 and 8 are kind of the same thing. And then the final step is stonks, is money. So if you're lucky enough and your decentralized application is helping a lot of people, or it's adding value, in theory, you should make money, but in some cases, you don't even have to add value, it seems. But anyways, we'll leave that for a separate conversation. Okay, so let's look at some code, but before doing that, I'm gonna hop back in to see if there are any questions. If you want 10K ETH, you should be hiring me instead. Yeah, man, if I had 10K ETH, I'd just be doing workshops all the time. Okay, so let's look at some code. I've prepared a repo here for you. I've also shared it in our Discord channel for Hypotenuse Labs. So feel free to check that out if you want to follow along instead of watching me do a few things. But I've got my repo open here. We've got 2 directories that we care about. The first few steps that we've discussed are dealt with in the token directory. So there's a bunch of things that you have to install. Check out the package.json to see what are the packages that you care about. These being in dependencies is probably a mistake. This whole thing can be in dev dependencies, just because we're not actually going into the app with any of this stuff. This is all happening on the local machine. But anyways, that's besides the point. You can check out the package.json for the packages that we care about. And then the next step beyond that is to look at something called hardhat.config.ts. So this is the hardhat configuration. This is the thing that's going to allow us to launch contracts and define to hardhat what are some of the networks that we're dealing with. So for example, I have a network here named hardhat, which is essentially the local network. And that's why it has the chain ID 1337. I can import certain accounts into this chain in order for my code to know what accounts I'm deploying the smart contract from. Beyond localhost, I can also define the endpoints for test networks, or even the mainnet. In this case, I have the Infura for Rinkeby, and the same thing for Robston. Of course, you have to sign up to Infura and place your API key here. You'd also have to go to MetaMask, create accounts, and import the private key. So let's go let's go actually do that very quickly. I just want to show you where that's done from. So if you go here, pick, let's say, yeah, sure, Robson, doesn't really matter. And then you go into this button right here, and then click account details, and then click export private key. You put in your MetaMask password, and then you'll get your private key, and then you use that private key in the code over here in order to make sure that our code is able to deploy contracts. Generally speaking, you should never ever put your private key in code and then push it. So this could ideally come from like a process.env value. You can always have like let's say mainnet. It doesn't matter for the testing networks because all these coins are worth nothing on the testnet, but on the mainnet you probably want to do it with like process.env.mainnet private key, something like that, and then use that in your mainnet private key definition. Just because if you push that, it'll disappear faster than you can open MetaMask. Okay, so we've got our configs here. Fantastic. We've got hard hat installed. The next thing that we want to do, we said, is we want to make sure that our contract exists. So I've got a contracts directory here. And within contracts, I've got a file called counter.sol. SOL stands for Solidity. At the very top, you have to define the Solidity version that you're using, and then define the contract. And by the way, Solidity is what we call a contract-oriented programming language. And when I say contract-oriented programming language, it's kind of like saying object-oriented programming language, but instead in Solidity, we define things called contracts. So you can even do things like extending one contract from another and things like that, rather than talking about the concept of classes. But let's keep going. So in this contract, we have a super simple contract. We've got a couple of things defined. Let's go through them. First thing, we've got a uint256, an unsigned integer, which starts at 0. Cannot be negative. And then we've got something called events. So events are really helpful if we want to listen to things that are happening within a specific contract or things that are occurring within a contract, but we don't necessarily want to call a function to get those values. So events are super useful for that. And then below that, you can define your functions. You can kind of start to see that it looks like a mix between, I don't know, C# and JavaScript type thing. That's kind of what it looks like. But it does have stronger type definitions that are specific to the EVM. Functions can either be view functions or functions that alter the state of the contract. So in this case, if I just want to get the count, it's a view function. It doesn't cost me anything to call that function, versus count up and count down. These are functions that actually change the state of the contract, and therefore I do have to pay what we call gas fees, or very small amounts of Ethereum in order to be able to use these functions. Oh, also a relatively recent addition to these contracts is you can actually use something like console.log in those contracts if you import hard hat console. And it becomes really useful because you'll actually get the logs of what's happening directly within the network, rather than having to potentially get errors that don't mean as much, or if you want to debug your contract, etc. Okay, awesome. So we've done a couple of steps so far. We've got our hard hat set up. We've got our contract set up. The next step for us to do is to actually run hard hat. There are two commands that we care about. So the first one being hard hat npx hard hat node. What this does is it runs a local version of, oops, let me step into the right folder. So we're stepping into token, that's where I have things installed. So npx hard hat node. What this does is it runs the local version of the blockchain. I mentioned to you that it gives you a bunch of accounts that you can use, and then for each account we've got a private key. So that's pretty good. We can take this private key, copy it over into hard hat config. We can put it over here, but we don't really need to, because the nice thing about hard hat is it actually automatically reads those, because it's the thing that's running the local network. So we don't have to do anything here. We just have to maybe import these accounts into MetaMask. So let's go ahead and do that. Oops, I stopped it. All right, let's take one of those private keys. I'm just going to take the first one, copy, go over to MetaMask. I'm going to select localhost 8545. This is the port that Hardhat is currently running on. And then what I can do is I can click this. I can add an account. So import account is what we want to select. And then I can paste my private key here. Is a duplicate. Oh, it looks like I've already imported this. Here, number 3, account number 3 is already imported. And I've got 10,000 ETH. Fantastic. So the next thing that we want to do is we actually want to compile what we did with the contract. We want to turn the contract that we built in Solidity into types that we can use in TypeScript. So let's start another terminal over here, and let's do a split. There we go. And let's go into token and run npx hardhat compile. And what that'll do is it'll generate a few folders for us that are super useful. I'm just going to start going a little bit faster because of time. But it'll generate a couple of folders for us that are super useful: artifacts, cache, and type chain. Type chain being the one that contains all of the types that we're going to use in our React application. So it also has factories, which will allow us to connect to the smart contract from React. So the next thing that we want to do is we want to copy those over to our application. So app src. I'm going to do the same thing with the other ones. App src. And the reason why I'm copying them over is because React doesn't allow us to do external imports. You can always change this in your configuration and have that work, but for the sake of this presentation, all we need to do is just copy things over. The main thing that we need really is type chain and artifacts. Okay, great. So I've got those now in my application folder inside of src. So I've got these 3 folders here. And the next thing that I want to do is I want to actually deploy this contract. So until now, I haven't deployed this contract. What I want to do is I want to deploy this contract. So let's go ahead and do that. This is the command for it, npx run, and then you have to specify which network you want to deploy to. The name of the network should match the networks that you've defined in your config file. So I've got hardhat over here, and then the script that I want to run is scripts deploy. If I were to open up scripts deploy from my token directory, what I'll be able to see is a few commands that will actually first get the contract factory. This is the reusable functions that hardhat provides for me for this contract. And then the next thing that I want to do is run the deploy function and wait for it. Once that's done, what I get back is the address of the contract, where this contract is at within this network, within this specific network. So if you're testing on a new network, for example, you have to get the address for that network. For me, it's local at the moment. And then the transaction hash or the transaction ID, and then which account it deployed from. So let's go ahead and try that. Okay, it's saying no need to generate newer typings. This is because we've already compiled. If we hadn't compiled, it would actually run the compile step and then do all of these things. So this is the thing that we care about right now. It's the counter contract address. But before we move on, you'll notice that the account that this contract deployed from is the first account. So hardhat just automatically takes the first account from the list of accounts it generates, but you can obviously specify this thing within the arguments of the deploy function. Just if you have many accounts and you wanna control which one is getting deployed from. Anyways, let's go ahead and copy this over. And now we can start to work fully within our React application. The first thing that we want to do is we want to have some sort of a .env file. You can do it without the .env file, but it's just nice to be able to configure things. And I'm going to place a variable called React App Smart Contract Address, which we will use in just a second. The next thing that we want to do is we want to actually go into our application. Once we've installed everything and we've got everything up and running, really the main library that's going to help us through a lot of these things is something called Web3 React. And it abstracts away a lot of the old way of doing things. So I'm just going to quickly go through what that does. The first thing that we want to do actually is to make sure that we're importing the types that we generated with type chain. So the counter factory and the counter type itself. And we can set it as in something as a state, or we don't even have to do that if you want to connect to the contract every single time, but it just helps to be able to connect to it once and then reuse it many times. And then the next thing that we want to do is have that connection run as a React effect. The connect function for a given contract factory takes in two things: the contract address, which we've set up in our .env. Here's where that's coming from, right here. And then the next argument is the signer. A signer is an abstraction of a wallet or an abstraction of an account. It allows you to sign transactions, approve transactions, and things as such. It doesn't have to be a signer all the time. If you're only doing read operations, then you need what is called a provider. But a signer is that one level up that allows you to actually send transactions that alter the state of the contract and not only read from the blockchain. The other useful thing that Web3 React provides for us is something called the activate function. And the activate function is another way of saying, I want to connect to MetaMask. So in the old way of doing things, and I have a separate file for that, you would actually have to, like send a request into window.ethereum, and then you have to mention what is the request name. But in our case, because we're using Web3 React, we just have to call the activate function. And then what you're looking at here, injected, this is the provider. And the reason why I've selected the injected provider is because it is injected within the browser. MetaMask is injected within the browser. Alternatively, we're talking about like a hardware wallet or something along those lines. The actual view of this is not that interesting, so let's not spend valuable time on that. We have our two functions over here, count up and, get count and count up. In both cases, we are using the contract functions to call this function that we're interested in. And the reason why we don't have to pass anything else to those functions is because we've already told the contract factory which account we're connecting from and what is the contract address. So really at this point, all we have to do is just call the contract function, unless of course the function itself takes some sort of an argument. All right, we've got 1 minute left, so I'm just gonna hop onto the app and I'm gonna do a start in the hopes of showing you what this all would look like. Let's check questions real quick. Okay, we can stay on for a few minutes if you need extra time. Yes, please. Having your private key in repo is like having your bank password on the sticker on your machine. Yeah, exactly. And also you'll get flagged from GitHub immediately if you do that. GitHub has these things that check. Okay, let's open up our inspector, our Chrome DevTools. Let's put that back in. Here we go. We've got our MetaMask. It's connected to a local network. Fantastic. Yeah, connect. Okay, great. And then now that I have everything in place, I can press the connect button. Let's see what's happening. I think I might need to do something over here. Let's do a refresh. Connect. Do I need to install something? Let's see. Oh no, I've commented out these two things over here, but essentially what these allow me to do is if it's an account that I've already connected to previously, these two functions allow me to just automatically pick up that connection. So let's see if that was the reason. Let me make sure I've got everything installed just in case, because it might be related to that. VM, npm. No, let's do yarn install. Okay, already up to date. And we've got the contract set up. Great. We can require things. Fantastic. Okay, let's start this again. We don't have to wait for that. We can just refresh this page. Ethereum.send is deprecated. Yes, I know that. We are not using it. Let's try with a separate account. Let's try changing the account into this one, for example. Okay, great. So we are getting an accounts changed hook, which is great. And what we want to do is make sure the connect function is actually doing what we want it to do. Okay, connect to MetaMask. It's calling activate. I suspect it's already connected, but it's not picking up on that. This before the presentation, I promise. And let's go back to the network, or let's go back to the account. Again, we're getting the hook, but we are not getting the page. So let's see what's going on there. App.tsx, wallet app, we've got the provider, we've got our contract address. Maybe let's print the contract address to make sure that we're reading it properly. Contract address, show us the contract address. Okay, great. And let's make sure locally everything is running. Great, maybe we can try importing another account and see how that reacts to it. Import account with the private key import. Okay. And we want to connect. Okay, so we are getting a payload for the connection. We are reading the account, but it looks like the user interface itself is has a bug, which I'm not going to fix in front of everybody right now, but we can see the events coming in the console. We can see when an account changes, and I'll double check the repo. I'll make sure that everything is good there. But I'm going to stop here, and I'm going to take any questions that you folks might have before taking too much of your time. Okay, doesn't look like we have questions. Let me check the Discord real quick, just to make sure that we're good there. We're good there as well. Okay, awesome. Well, if you do think of questions later, feel free to message us on our channel. The last thing I'm actually going to mention before wrapping this up is that we are hiring. So if you feel like this is for you, if you feel like you're interested in working on blockchain projects, we do have a lot of blockchain projects. So it might be you that we're looking for. And here's the link for where to apply. Thank you, everybody, for joining. We're going to wrap this up now. And again, feel free to reach out to us on Discord. Take care, everyone.